company 4 years ago to edit the complete materials of our first edition Living by Chemistry curriculum. And prior to that, I was a high school chemistry and middle school physical science teacher in the Bay Area in the Oakland Public School System. So I have taught with Living by Chemistry, I've edited the lessons, and now I do workshops and help people to learn about what I think is the best inquiry-based chemistry program that's out there right now. And here today with Mary Van Ogtrop, who is our web specialist and backup for me on the webinar. If you have any questions during the webinar, please use your chat panel, and either I will look at it and be able to respond, or more likely Mary will be keeping an eye on that and alerting me to when people have a question or a comment. Sometimes I'll be able to answer immediately. Other times we'll save that for later on in the webinar. So let's get started right away, because I want to make a good use of this one hour that we have. What is Living by Chemistry? Living by Chemistry is a standards-based high school curriculum where you are given the opportunity to teach an inquiry-based lesson every single day of the year. And so you're seeing an image of our beautiful student textbook, and our next image shows you that the curriculum is actually broken up into 6 major units, and each unit has its own theme. The themes are built into the curriculum to help ground the chemistry for students in their everyday lives. So the inquiry is all about the chemistry, and the themes help students to make sense of it in their own lives. So I'll give you a quick breakdown of each of the themes. In the first unit, Unit 1 Alchemy, which I will be doing a live workshop tomorrow at the NSTA Regional, where I am in New Orleans. So anybody that's in New Orleans, come down, and if you're at NSTA, come see it in person. But we start off with Unit 1 Alchemy, and we actually open up the year by taking an ordinary penny, placing it into a beaker that's filled with zinc and sodium hydroxide solution, and we heat that up. And the penny gets a zinc coating, and we pull it out and we show students that we have a silver-colored penny. We clean it off and put it on a hot plate, and the zinc and the copper on the surface of the penny go into solution, forming a beautiful golden color. And we asked students, did I just create gold in this classroom right in front of you? And as you can imagine, some students have never seen anything like that before, and they don't know what to say. Other students are a little bit more skeptical. Yeah, when I was doing this, I remember a student saying to me, Mr. Dowling, if you can make gold, why are you teaching high school? And it's a funny comment that you will probably hear if you've done this, but it's also a good comment to open up a discussion about, well then what did happen? And in fact, is it even possible to change copper into gold? So our whole first unit revolves around that theme, and students learn the chemistry that they would need to know to determine what occurred during the penny demonstration, and in fact, is it possible for one element to change into another element? So students are studying the concept of what is matter. They're looking at atomic models, and we move into chemical bonding. And I'm seeing a comment actually from Diane that says it works better with pre-1980 pennies made mostly out of copper, and I agree. It's a little bit harder to do it with the post-1982 pennies, but I have successfully done it in many workshops. So thanks for pointing that out, Diane. So in Unit 1 Alchemy, we finish the unit by covering 4 models of bonding, and we focus on ionic bonding, at which point we jump to Unit 2, Smells. The overarching theme here is, how does the nose know? Why is it that we smell certain compounds and not others? And and this is an opportunity for us to explore molecular structure and properties. We'll be doing that today, so I'll move on to the next unit. Unit 3, Weather, we relate chemistry to what is occurring in the atmosphere. So this is a chance for students, after they've explored the atomic and molecular structure and the models that we have for the atomic and molecular level, now we want to move students into thinking about, well, what occurs, when these molecules are moving around, what changes can occur. Unit 3 covers phase changes, physical changes, and all of our gas laws, and we use closed containers to model what might be happening in the atmosphere in large air masses that are relatively uniform in in their makeup. So we move on, oops, I skipped one. We move on to Unit 4, toxins. So Unit 3 is covering our physical changes. Unit 4 will move into chemical changes, and we also address the concept of how much is too much. So we're looking at amounts here. How much aspirin should an adult person, take to relieve a headache, and how much aspirin would be appropriate for a small child. It makes, these amounts are important, and we're relating to students the concept of toxicity. And so all the chemistry revolves around that, and students are, of course, looking at mass mole conversions. They're doing their stoichiometry. We're covering solutions. We're looking at acids and bases. And we move from there to Unit 5, fire, where we explore the nature of fire and cover our energy concepts, thermodynamics, and redox in detail. And we end the year with teaching lessons about reversible reactions and equilibrium, and students at the end of this year, if you make it through this entire curriculum, students will be doing a demonstration illustrating these principles, illustrating Le Chatelier's principle and reversible reactions. So just to sum it up, it's a full year of standards-based chemistry where the inquiry is all about the chemistry, grounded in 6 major themes so that students can see how this relates to their own lives. And the student textbook that you see on the left has, of course, all the units in one. You as a teacher would get 6 individual teacher guides. So let's jump into a lesson. Living by chemistry, what shape is that smell? This workshop is all about Unit 2. And today when I was in our workshop, I put this up on our overhead project, with our PowerPoint, and this would be up on the board or on the PowerPoint or on your overhead projector when students come into class. Every single day there's what we call a chem catalyst to begin the class, and students know that there are no wrong answers to this chem catalyst. They know that that they're being asked to put down whatever they can come up with to answer the questions and to explain their responses. This is an opportunity for you as a teacher to assess their prior knowledge. What do they know when they come in? So let's open this up to chat feature interaction. What would your students say to you if you ask them, what do you think is happening when you smell something? And then why do you think we have a sense of smell? Let's start with number 1. What do you think is happening when you smell something? And I might, if students aren't sure what to say, I might say, well, how exactly is it that we smell something? Do you have to take that substance and physically place it inside of your nose to smell it? What might students say to question number 1? So take a minute and maybe type in a response to your chat panel. I'd like to hear what you think your first-year students might say to this question. And Mary, if you can keep an eye on that for me.
You bet.
All right, so I'm seeing some students might say, stuff is entering my nose. That's what Dennis is telling us. Susan said it has to be a gas. And that's an important thing right there. It does have to be a gas. And you're finding out from students if they're thinking about this at the atomic and molecular level and at a phase, solid, liquid, and gas phase. Particles are moving through the air into my nose. Nancy says her students might say that. Diane says that gas with the chemicals of the odor go into my nose. So these are all responses that you might get from students, and this is a great way to start the class and to help you determine how much the students know. For example, students might think that they can smell metal. They might describe something as having a metallic smell, and that would give you information about what they might know or not know about solids, liquids, and gases. We're not going to smell something like a salt or a metal because in order for that to be a vapor, it would be at such a high temperature that we'd be injured before we would really smell it. And so when somebody says something has a metallic smell, they're actually smelling something that's molecular that might be interacting on that metal. Number 2, and it's okay if students think that that they can smell salt or that they can smell something else. This whole unit is going to help to get them to see the mechanism of smell and the chemistry that they need to know to explain this. Question number 2, what might they say to why do you think we have a sense of smell? So why do you think we have a sense of smell? To know if something is hazardous. Jane says her students might be saying that this is helpful for us as people. Why, to protect us from dangerous things. It helps us to know if the food that we're eating is good or bad, right? Yeah, to find food. What else
Or
might
a
students
mate?
say? Maybe to find a mate. And I remember teaching middle school, and there were a lot of smells in the middle school classroom. Let me tell you, because students haven't quite got their hygiene routines figured out, and they're putting on body sprays and all sorts of things. And so there's and students might have heard about pheromones in different species, etc. So there are all sorts of reasons why we might have a sense of smell, but this is also current research. So it's okay that students may or may not have an answer for this, and in fact sometimes when something smells good, it doesn't mean that it's good enough for us to eat. Same with taste. Something can taste very good, but it can be very dangerous for you. The example that came up today in our workshop is ethylene glycol, which is antifreeze. Apparently it tastes delicious. And it was used as a solvent in medicines before the FDA was formed, and that was part of the reason why the FDA was put together, because there are dangers and hazards with chemicals that people are touching or tasting that weren't being regulated. So it is possible that having a sense of smell can really help us. If you smell smoke, you might be protecting yourself from a fire. If a particular fruit or food or berry smells good, it might not be good to eat. So it's a good discussion that we can have in the beginning of class. Every student can say something to these questions, and it's not high stakes. It's not about getting it right or wrong. And so this right away, for me when I was teaching, this shifted the whole dynamic of my classroom, because now students are participating from the beginning and not waiting for just a few students who are normally maybe more motivated to learn chemistry. Let's move on to our next slide. I'm having a little technical difficulty. This particular activity is going to be, if you were doing this in class, you would be wanting to talk to students about some of the safety issues that would come up, and we're going to be smelling different chemicals, and sometimes those chemicals can be strong or caustic. The ones in this lab are not. They're all very safe. They're all things that you can get over the counter, or like an essential oil that you could get at a Bath and Body shop. We want to teach students the appropriate wafting technique, which many many do not employ, but this particular unit and lesson will get them to learn why that's important. And you might talk to students about allergies that they might have. You might open windows. All of these things are safety precautions that you would normally take for any chemistry lab that would have vapors that could be somewhat caustic or harmful. But these are not. What we're doing with our laboratory today is, you can see on the screen, I have 5 glass vials with plastic lids labeled A through E, and inside of each vial is a cotton ball, and on each cotton ball I've placed a few drops of substances that have a particular odor. Now these substances are mixtures, they're oils or something that have other components, but there's one component that has a distinct odor, and that is what we're going to be having students examine today in the laboratory. What we ask them to do is we ask them to smell the compounds using the wafting technique and tell us, is it sweet, minty, or fishy? And we have these broad categories so that we can prevent having too many different smell names that students might come up with. Somebody might think, oh, this smells like tropical fruit punch, or someone else might think it smells like a candy or bubble gum, and it's very difficult actually when we describe smells. We often compare it to something else. So we want all of those examples would fall under a sweet category as opposed to a minty category or a fishy category, and you'll see why as we move on. But so in this laboratory today, I handed out smells vials to the workshop participants, and they opened up the vials and individually they smelled them. Then they came to consensus with their group, and then we actually came to consensus as an entire classroom. And you can do this whatever way you want to in the classroom, but we encourage you to have students come to consensus for several reasons. For one, not everybody can smell everything. Our sense of smell might differ. Some people actually cannot smell anything for whatever reason that occurs, that they don't have a sense of smell. And some people are more sensitive and can detect the scent in a different way than someone else. And so we want everyone's individual experiences to be validated, but we want to talk about consensus so that we can do a scientific study of the smells. So let's run down and take a look at what if you had been there today, or if you taught this in your classroom, what students would experience. So we asked Andres and Afia in our key laboratory to smell these substances, and you can see they're using the wafting technique. They're not putting it right up to their nose, and students will probably do that. It shouldn't hurt them. It'll be a little stronger, but we want to show them the right technique. And they thought that this one smelled sort of minty. So they told us that it fell into the minty category for them. The next smell, as you can see, was not as pleasant, and they reported that smelled like the fish that I took at one of the farmers markets in New Orleans I photographed, and so they labeled that as fishy. Their next smell seems like a little bit more pleasant, and they said that it smelled like pineapples, actually, like a kind of a pineapple candy or pineapple syrup, and so they labeled that as sweet. And that's an example where you might get a lot of different responses. Oh, it's like a pineapple smell to somebody. It might be like a tropical fruit drink to someone else. It might even smell like a banana or even coconut, because often these things are mixed together in flavorings and etc. But it's a pineapple smell, so it's sweet. Also, you can predict from their happy expressions that D also is sweet, and in fact it smelled like bananas. And then finally they smelled this one, and they had to think it over for a bit, and they said that it smelled like spearmint gum. And so they classified that as minty. So now we have a set of data, and as I said, we had a little difficulty with the worksheets, but students actually have a worksheet that we can send to you so that you can use this in class, where they record their own individual response, and they record the group consensus, and it usually works out that students can get to this consensus pretty quickly. So A, minty; B, fishy; C and D, sweet; and E is minty. And we ask them to fill it in the next part of the worksheet. And thank you, Andres and Afia, for being our testers. We have them fill out a worksheet where they can now see, in addition to the smell, now we want to show them, here are some chemical names and molecular formulas that we want you to look at, and tell us the patterns that you notice. So go ahead and chime in silently with your chat feature on any patterns that you think students might notice that are related to the smells and the compound names and the molecular formulas. So what might students notice right away? So Jill said that her students might see that there are 10 carbons in the minty smelling compounds. So that's something they might notice. What else might they notice?
See, many have carbon, oxygen, and hydrogen in common.
Many of them do. In fact, this is an important thing to point out. All of them have carbon and hydrogen, and all but one have oxygen. So here we are getting a chance to introduce organic chemistry concepts to students early on in the year, which normally would wait till the end. I want to look at some of the other comments that people are noticing, because there are many patterns. Let's see.
The fishy smells of nitrogen.
The fishy smell
Susan
had
and Jane said
nitrogen.
that.
Nitrogen, fishy. What might students notice about the names and the smell categories?
Let's see.
In fact,
Nancy said that minty substances have O-N-E in the name.
okay, so O-N-E is the ending for the minties. What about any other naming patterns? ATE, Jane is saying. So we're seeing pentyl propionate and isopentyl acetate, both ending in ATE, and they're both sweet. A carvone and menthone ended in O-N-E, and they were both minty. The fishy has a different ending than all of them, amine, and it also was the only one with the nitrogen. So these are all interesting things that students are pointing out. Let's see. Diane is saying compounds with one. I think she's saying one oxygen are minty, and each of them have 10 carbons. Those that are sweet have 2 oxygens. So in the formulas, the molecular formulas, if there's 1 oxygen, it was a minty smell. If there were 2 oxygens, there was a sweet smell. I think I saw somebody make a comment about ratios. Nancy said there was a 2-to-1 ratio of hydrogen to carbon in the sweet substances. So for those of you that are seeing that, for example, 16 hydrogens to 8 carbons in vial C, 14 hydrogens to 7 in D, and we're not seeing that in the minty or the fishy. So you're seeing that there are lots and lots of patterns that students can point out. We might ask them at this point to, after they did this worksheet together, we would be discussing those patterns as we're doing now, and I might ask the students to come up with a hypothesis about, how they could predict the smell of a compound. And maybe I would say, what information would you want to know about a compound in order to predict its smell? So what might students say to that? What might they want to know in order to predict the smell? Based on today's lab, if I had another vial that, vial F, what information would you want to know in order to make a good prediction? So let's see if anyone wants to chime in on that one. Take just a moment.
Nancy
Okay, so Nancy's saying that her
formula.
students would want to know the chemical formula, so and the name, right? So Deborah's adding the name and formula. So to make a good prediction, if we knew the name of the compound and the formula, we might be able to predict the smell. So we would go on to, that was our hypothesis. If you know its name and formula, you might be able to predict it. Now this hypothesis might hold true, and we might need to modify this hypothesis. In fact, students will be modifying it throughout the unit. But here's our check-in question at the end. Imagine you had a compound that has 9 carbons, 18 hydrogens, and 2 oxygens. How do you think it will smell? And explain. Getting just what the smell is not even as important as why a student might think it smells that way. So Diane is saying sweet. Can you tell us, Diane, why your students might say that? What would lead them to believe that what would lead them to predict? And so
She noted the ratio again. The oxygen to carbon ratio is 2 to 1.
Or actually, it's the hydrogen to carbon, right? Hydrogen, carbon, and 2 to 1. But there's 2 oxygens, right? Sweet because of the ratio and the 2 oxygens. So based on today's inquiry-based lesson, students are giving an evidence-based reason for their response. Now, how sure would they be of this prediction after doing an activity like this? Would they be like, yeah, it's definitely going to be sweet, or would there be any doubt? What do you think? How definite, can we be at this point? And
Don't be shy. No wrong answers.
wrong answer, right? This is all our inquiry-based workshop that we do, and again, it's imagining what your students would say. So and so Susan's saying fairly sure. But there are a few examples, and Nancy is saying they'd want to smell more substances. A lot of students might be really confident and say that's definitely going to be sweet, but there are going to be other students that will point out, we only smelled 5 things.
Liz says they'd be very sure, but they would be afraid of being tricked into smelling something fishy.
Right, and often, right, they might even just know by that question, maybe I shouldn't be so sure. Why would you be asking me in the first place? And it's a good chance to talk to students again about scientific methods. We came up with a hypothesis. We only smelled a few things. So the logical next step would be to smell more substances. And that's in fact what we'll be doing. But for homework tonight, we're going to assign our reading in our student textbook. And so for those of you who are familiar with our textbook. First of all, maybe chime in. Are those of you who are not currently using Living by Chemistry, if you're not using Living by Chemistry, are you using a textbook very often in class? Let me know if you're using your student textbook, because I want to point out some differences about our textbook, and I'd like to know whether or not the current book that you're using, if anyone wants to share about that.
Okay, so Michelle says not using the text very often.
And any reason why you might want to give about that? So Jill says there's so much in the textbook that it's hard to assign the readings. And Susan, you're using 2 different ChemCom and ZoomDoll for regular and advanced. Why might you not use your ZoomDoll for the regular? when I do this poll in a workshop, what I often see when I say, how many of you are currently using your textbook if you're not already using Living by Chemistry, about half the room usually raises their hand. Um, and and I ask teachers, well, why aren't you using your textbook? This is a major resource that your school has allocated funding for, and you won't get to buy a new one probably for 7 years. And often teachers are saying that the textbook doesn't go along with the really great lessons that they're planning every day. It doesn't really match up well. Sometimes they're saying that the book that their school has adopted is technically difficult for their students to read through, and that their students aren't reading it, or that when they are reading it, if they don't understand something, they just stop. Often the traditional textbooks that are out on the market, they're great textbooks. In terms of the content, the chemistry is really good. Many of them have been around for years, but often a more traditional textbook is a reference tool that's great for you as the teacher. But if it's your first year learning chemistry, really learning chemistry for a full year, and your resource is something that's written at the level that somebody needs to understand chemistry already, it becomes a very difficult resource to use in the classroom. So what we did, and I'll let you take a look at it for this lesson, we created a textbook that is very studently, and you can see that for this particular lesson, there's a 3-page reading. So 1, 2, and 3. So it's definitely doable in one night. It's not too much to read. It relates exactly to what we did in class. So let me enlarge that so you can see what I mean by that. Students, when they first take a look, they are, hold on just a moment, I need to scroll.
Jeffrey, do you know offhand the reading level of LBC?
It has a Lexi level of 1030, and there are some other reading level metrics that we've used that you can look up on the website. But this is something that probably an 8th grade reading level, students would be able to read it. So students we're trying to adjust the idea that sometimes when the language is so complicated, even students who have high literacy struggle. We wanted to create a textbook that all the students would be able to utilize. And so we're not leaving anything out. This is all very rigorous chemistry, but the way in which we write about it is in language that we think students can understand. And because students have had an activity during the day and then review at night, so here again, let's explore the sense of smell. Let's classify some smells. You can see the image here is the exact laboratory that we just did. 5 different vials, but we have some new, some similar and some new names and formulas, and these patterns that students would be looking at, they get to reflect again on it. Students get to do practice problems and examples, and at the end we have exercises for reading comprehension, and our reason and apply our practice problems. So this is a chance for students to reflect on what they did in class that day, to kind of catch up if they were struggling a little bit during the class. They get to reflect again and review what they did. They get to do practice problems every single day, so you have a homework assignment every single day. Maybe we throw up, for